Okay, let me share the whiteboard. Okay, so what point did you like get up to on
I did the quotient rule, and then I took the square root of x to, the denominator, and then that's where I stopped.
Okay.
So at the top, I still have 1 minus x plus 2 square root of x, and then I didn't know how to simplify from there, the numerator.
Okay, let me just write this really quick. Okay, so we have 1 minus x times, over root x, right? Oh, I'm writing this kind of poorly, plus 2 root x over what did you say?
Over 1 minus x squared.
1 minus x squared. Okay, so basically when you have something like this, like on the top, there's like in the numerator, if there's a fraction, what you're going to try to, and there's like two, sort of numbers here, like 2 root x and then 1 minus x over root x. What you're going to try to do is create a common denominator between the two.
On the top.
Yes,
like
on the top. Yeah, you're just looking at the top. And so you see that the common denominator here is root x, right? Like that's the denominator that you need.
Okay, so then it would just be.
So then you would get
x over root x.
So then you would get 1 minus x, and then when you multiply, okay, let me just write this right here. Oh my gosh.
Yeah, okay, I get it now.
Yeah, that makes sense, right?
And so I just took the root x to the denominator without making both of the terms in the numerator have the same denominator. If that makes sense. So I think that's where I went wrong.
Yeah, and then once you do this, you can get 1 minus x. Oh wait, no. Oh my god. Hold on. Once you do this, you can just simplify as 1 plus x over root x times 1 minus x squared. And that is the answer, I think. Yeah.
Yeah, that's the answer.
Okay, does that make sense?
Yeah, that makes sense. Thank you.
Okay, cool. Okay, is there another one that?
Yeah, hang on, let me write this down.
Oh, I'm so sorry, I cleared it. Should I have?
No, I got it.
Okay, my bad. Oh, number 7 is really weird. It was so irritating. Oh my god.
Number 7.
Yeah, because you basically have to use like log rules, and it's like really, I don't know.
Okay, so I just barely started that one. I was explaining it to everyone else as I was doing all of these, so I think that's why we didn't get that far, because we were all trying to work together. And then some of us were studying for Spanish, so.
Oh.
Yeah. Hold on, sorry. Okay, so for number 7, I started using the chain rule. But I just barely got to writing down the very basic derivative, and I didn't go any further. So what I had so far was x times. So okay.
So basically,
if we use the chain rule on the the e to the power of ln 2 to the power of x, would it be x e to the power of ln 2 time to the power of x minus 1, like that? Is that how we would write it?
Sorry, say that again.
So since we have to subtract 1 from the exponent, within the exponent would then be x minus 1? Is that how we would write it?
Okay, no. Here's what you're going to do with this. This will just become e to the x ln 2. That's what this will become. Because then you're just simplifying it.
Okay.
Okay, yeah. So then after you do that, basically, the e rule, which is where you bring this to the bottom and then you keep it the same. So then the derivative of this is going to be, oh my god, what am I doing? Is going to be ln 2 times e to the x ln 2.
Where does that x go? Oh, the x stays there.
Yeah.
Okay. Okay, that makes sense. is that just the answer? Or do we have to
No,
simplify more?
basically, okay, there's a rule, basically. Okay, hold on. Basically, the rule is that, like, okay, basically ln of e is 1, right? I don't know if you know
Right.
that, but
Yeah.
yeah. So then e to the power of, we're just going to use b here in this situation, okay? E to the power of ln b equals b.
That makes sense.
Yeah. So in this case, we have e to the power of ln 2. So we can bring the 2 down, and then x stays as an exponent. So then it becomes 2 to the power of x times ln 2. And then this is the answer.
Interesting.
I don't know if we're actually going to need to know this for the test. So
I have literally never heard of this rule before, and we did not learn it. Last year we did log rules, right?
yeah.
Did not teach us this rule. Oh, we didn't talk about
ln.
we talked about ln, but we didn't talk about this at all.
Yeah, I don't know. I don't know. And then
I thought I would be prepared for this test because like the stuff that we were doing, like I actually understood what we were doing like this unit a lot better than last unit. But this study guide threw me off a lot.
no, yeah, I don't know. The study guide is completely different from what we've been doing. So I don't really know. And then basically using this like rule here, you can figure out what b is.
Okay, yeah, I didn't even look at B yet, so
Can I clear this?
yeah.
Okay. So for b, basically it's asking like b to the x, right? Something like that. Yeah.
Yeah, show that if y equals b to the power of x, where b is more than 0, and b is not equal to 1, then the derivative equals b to the power of x times ln b.
So you basically use that thing where it's like e to the power of ln b equals b. So then this equals e ln, oh my god, that was not an n. E ln b to the power of x. And then you basically just do the same thing that you did and you get e ln.
Wait, why would we put that in for b?
Because you're trying to prove something with ln in it, like b to the power of x times ln b. And so you know that this equals b. You just have to know that. You just have to know that the rule is this.
Okay.
I don't know. It's like
That's
really
strange
weird.
because b could literally be like, it doesn't say that it's specifically for this, right? Like it
I
could
don't know.
be
I think
could
it's
be
just because
anything.
I think it's just because it tells you that it's b to the power of x times ln b that you have to assume to use the e to the ln b rule.
Yeah, I wish they'd made it clearer because we've never seen this rule
Yeah, and
before.
then you just get e to the x ln b equals b to the x. Oh, Miss Sinha's going crazy.
Wait, what did you do?
So basically you replace b with this,
Mm-hmm.
with e to the ln b,
Yeah.
and then you get, okay, I'll just write this right here, x e to the x ln b. So it's like basically the same thing that we got in A.
Okay.
And then you do like the derivative of this. And
Oh,
you
okay.
yeah, and then you just get this.
That makes sense. I wish you just taught it to us. Like, like she didn't mention this at all. So
Mhm.
yeah. Okay. Did you do the third part of 5?
Yes, I did. I can do that one as well.
Then we can do 20 together after this if you want to. It's the last one.
Yeah, that's okay. I can do that. Time. I'm just trying to see if there's like another really hard one to do, just to make sure. Okay, probably after that, I would say we can do 5, like the third part of 5.
Mhm.
And I would say we can do 16 because that takes some simplification and
Okay.
just so that you can practice them. Also, I think one of them is wrong, like the answer key, but I'm gonna have to ask Miss Sinha.
Was the answer key on, where did you find the
Yeah,
answer?
The answer key is on Schoology.
Oh, okay.
I think it's part 3 of 8. I think it's wrong. So we'll see. Okay, let's clear this. Yeah, okay, basically it's e to the x plus 2. Okay, 1 second. Okay, yes.
For this one, I got through like I put everything into the quotient rule and then I just didn't know where to go from there because there was a lot.
Times e to the x plus minus. Oh wait, yeah, minus e to the x plus 2 times negative e to the negative x over e to the negative x plus 1 squared. Okay, so you got here.
Yeah.
Okay. So what we're going to do to simplify is we're going to, because there's a lot of e to the x's, it's easier to distribute. So basically what we're going to do is that e to the negative x times e to the x is just e to the 0, which is 1, right?
Why is it e to the 0?
Because when you're multiplying, like when you're multiplying things that have something in the exponent, you add the exponents, right?
Right.
And negative x plus x is 0. You get e to the 0. Okay, let's just write it down. 0 plus e to the x, which is just saying like plus e, wait, what is this? Plus e to the 0 again, plus 2e to the negative x. Does this make sense?
Yeah.
Okay, are you sure? I just want to make sure.
Yeah. No, I was wondering about the sign in front of the 2, but yeah, it would be negative because there's 2 negatives.
Yeah, because it's minus and then it's negative e to the negative x. Okay, yeah, so then you get this. I'm just going to ignore the denominator for now.
Okay.
And then this is 1. This is 1. So then you get e to the x plus 2e to the negative x plus 2 over e to the negative x plus 1 squared.
Would we factor? What's on the top?
I don't know. I wouldn't. I don't think you can actually.
Yeah, actually, yeah, I don't think we can factor it. Is that, do we just leave it?
Yeah, that's the answer.
Okay.
I think that's the furthest you can simplify.
Okay. The easiest one so far are the ones that I've done with 6. 6 was really easy. 2 made no sense whatsoever.
Wait, 2 is crazy. 2 is crazy. So
because I tried asking Samita about it and she told me that I broke the rules of math and not to worry about it. So
yeah, I think the answer key is wrong because there's this thing called implicit differentiation. And like, that's kind of what you have to do here because you have x equals y to the power of 1/3. But like in the answer key, she did something different, but I don't think you can do what she did in the answer key.
you never learned that.
Yeah, I don't think she'll ask about that, hopefully. But yeah, the number 2 is very strange. So I don't think she'll ask that.
She would actually make
like
the test.
Yeah, probably not.
Okay.
But yeah, then
should we do 16?
Yeah. If you want to do it first, sure. Or if you want me to do it as well.
At what point on the curve f of x equals x over square root of x squared plus 1 does tangent have gradient 1? Wait, is it saying,
Like at what point when x equals what does the derivative equal 1?
that's an interesting question. So first we would just take the derivative, right? And then
Yeah, first you take the derivative.
and then just plug in 1 for y prime.
Yeah, and
Okay.
then you solve for x.
That doesn't
Want me to-
seem that hard.
There's just some simplification here.
Okay. Let's try this.
Okay,
Y prime equals,
just do it for the people if anybody's watching.
yeah. Okay, y prime equals v, which is x square root of x squared plus 1, times u prime, which is just 1, minus u, which is x, times 1/2 square root of x squared plus 1 times 2x over x squared plus 1. Hold on, I need to get more paper.
No problem.
Why did you set x squared plus 1 equal to 1?
Okay, basically this whole thing has to equal 1. And so in order for the denominator, the only way this can equal 1 is if the denominator equals 1. So I set this equal to 1. Okay, yeah, for the people watching, if there's anybody here, I'll just explain what I did.
Yeah.
So basically, first you do quotient rule. So you do square root x squared plus 1 times 1, which is x. 1 is the derivative of x, minus x times the derivative of square root x squared plus 1, which is just 1 over 2 square root x squared plus 1. And then because you're doing chain rule, you have to do the derivative of this, which is just 2x. And then I just, distributed those things. And so that's how I got 2x squared on the top here and 2 at the bottom. And then I found a common, I honestly could have canceled 2 right here, but I don't know, I just didn't do that. And then you find the common denominator, which is 2 square root x squared plus 1, or just x squared, square root x squared plus 1, however you simplified. And then I got 2 times x squared plus 1 minus 2x squared. And then you distribute this. And then once you get that, these two cancel. And then you can simplify because there's, 2 and 2 on the bottom. And then you get 1 over x squared plus 1. And then because you have on the numerator, you have over square root x squared plus 1. And on the denominator, you just have x squared plus 1. So that's something to the power of 1 plus something to the power of 1/2. So then you're adding the exponents. So 1 plus 1/2 is 3 over 2. So then x squared plus 1 to the power of 3 over 2. And then this has to equal 1 because that's what it says in the problem. So then the only way this can equal 1 is if the denominator is equal to 1. So then you set x squared plus 1 equal to 1. And the only way that can happen is if x is 0. Okay, hopefully that made sense.
I think that was pretty good. Are there any others that were like harder? Because if we're gonna record those, I think that would be helpful to most people.
I don't think so. I think all the other ones are pretty fine.
Okay. I don't think anyone said anything specific that they needed help with. So
yeah, the only other one that's like a little bit long is like the second part of 8, but it's not bad. So I think.
I guess we can just do that one, and then I guess we can just end here. I guess like there's nothing else really to work on.
Yeah. We could either do 8 or we could do 11 part A because that's the second derivative. So if we want to do that,
let's do that one then.
We'll do the first part of 11.
Find f prime prime. You say f prime prime?
You say f double prime.
F double prime. Find f double prime of x given that f of x equals x plus 2 over 2x minus 1.
Yeah, so we're gonna
do quotient rule. So do we find the first derivative and then we take the derivative of that, right?
Yeah. Do you want to write this one?
Yeah, sure.
Okay, I'll stop sharing then. My hair looks so bad.
Well, I think you need to have messy hair while you study for math. Otherwise, it's the wrong legs.
Okay.
I'm gonna make this bigger. Okay, there we go. Okay, f of x equals x plus 2 over 2x minus 1. Okay, so first let's do y prime equals v u prime minus u v prime over v squared. X plus 1 minus 2x minus 4. I just distributed this and then subtracted it. And then 2x minus 1 squared. Do we just simplify from there and that's it?
Yeah, you just simplify.
No factoring, right? Okay. Way. Okay, and this is the first one?
Yes, this is the first derivative.
Okay. Then second one, what is it doing? Okay. Quotient rule again, right? So
yes, quotient rule again.
Okay, so v u prime, that is 0, right? Minus u. Okay, is there a way to like shift to the left? Oh well. And then for v prime, chain rule, so times 2 over 1 squared. Okay. That goes away. Plus 5 or positive 5, right? Times 4x minus 2 times 2. I don't know. I'm not explaining this as I do it, Alina. So if you want to, like, I don't know, explain what I'm doing.
Okay, yeah, sure. So basically what she did first was quotient rule, just like for the first derivative. So, just the bottom minus the derivative of the top minus the top minus the derivative of the bottom. And then she just distributed the 2 to get 2x. And then she got, like, it's just 2x minus 1 minus 2x minus 4 over 2x minus 1 squared. And then she got negative 5 over 2x minus 1 squared. So that's the answer of the first derivative, but it's asking us the second derivative. So then we got at the top, wait a minute. Oh, okay, basically, okay, wait, I'll explain this when we get there. Okay, so then you do quotient rule again. So you do, the bottom times the derivative of the top, which is 0. So then you can cancel that minus the top times the derivative of the bottom. So because it's 2x minus 1 to the power of 2, you do chain rule. So you get 2 times 2x minus 1 close parentheses times 2, because that's chain rule. And so then you get, so then you do, okay, here's how to make it a little bit easier. I'm going to annotate this. So at the top, you see you get negative 5. So you're going to leave the 2x minus 1 in the parentheses. And so like you did, you're going to do 5 times 2 times 2, which is 20 times 2x minus 1 over 2x minus 1 to the power of 4. Because then if you do it like this, then you can simplify even further and get 20 over 2x minus 1 to the power of 3.
Okay.
So
that was
this is,
I think.
Yeah.
Okay.
So if you see like a common term in the top and the bottom, like something with x, then try and leave that the same to see if you can simplify. Okay, yeah.
Okay. Anything else that we should go over?
I think this is fine, and then we could probably do it tomorrow if people want that.
Yeah, we can ask, I guess. I don't want to do it again. It's gonna come. So
yeah.
Okay.
We can just ask it.
Let me stop recording.